Hey out there in Training Tuesday world. My name is Heidi Reese. I am the training program manager for Dayton Superior. I want to thank you for taking the time to attend our training today. We're so glad that you're here. Chuck and I are hanging out. Say hi, Chuck, real loud.
How you doing?
There you go.
You're back.
I don't know if you knew I was on vacation. Well, if you listened last Tuesday, I was, and I didn't have internet. So good thing Chuck could do it himself. So anyway, before we get started today, I want to remind everyone that they have joined muted so that the presentation can be conducted without any outside disruptions. But I don't want that to stop you from asking any questions that you may have. You can do that through the Zoom functionality of the chat or question and answer section. And at the end, we'll have a mini question and answer, and we can get that taken care of for you. Also, as a reminder, we put every one of these out on our YouTube channel. So obviously we record them, and you can also access them on DaytonSuperior.com. Just search Training Tuesday. You get two links, one to sign up for the next one and the other to see what has been done in the past. They're all organized by forming, shoring, tilt up, precast, you name it. So you can find what you need, when you need it, where you need it. All right, so this presentation that we're about to go over is intended for training purposes only. Anything technical or any products that we mention within this, this PowerPoint, please refer to DaytonSuperior.com. You can find the technical TDSs, the safety data sheets if those are applicable, as well as any application guides, handbooks, you name it, all out on DaytonSuperior.com. So as you know, we are the leading solution provider of the concrete construction industry. We deal with products, support, engineering, and training, and a fight song for those of you. Thank you, Tyler. Go Iowa. So we handle the products, accessories, chemicals, forming. We're going to be talking about Maxiform STS, and I let the cat out of the bag, or Tyler did. So Tyler Shaner is going to be talking to us a little bit about that product and the amount of time that we can, because Maxiform's a pretty big product, but it is awesome, and we're going to show you how it's done, show you some application videos. Let me tell you a little bit about Mr. Tyler Shaner. He is Dayton Superior, or I should say Symons, Director of Engineering, Forming, and Shoring, and is one of our top product experts for Symons. He really is. He has a BS in Civil Engineering from Iowa State. Couldn't really guess that from that fight song cell phone call that you just got. And he also has an Executive Master's degree in Business. So at least he can talk that portion with me, because I have two civil engineering brothers and don't know crap when they start talking to me about that. So he is here to talk to us about all of those aspects. He's been working in this industry for over 29 years and a fantastic resource for forming projects, products, as well as engineering services. So take it away.
All right, thanks, Heidi. I do appreciate that, and pretty excited to be able to talk to you about one of our great systems, Maxiform STS. And again, this is going to be a basic introduction to the system. And I'm going to start with a little bit of history on where self-spanning formwork, Maxiform specific, came from and started, why it started, and then why we developed, coming up on about 9 years ago, the Maxiform STS system. So to start off, I'll talk a little bit about the history and why, self-spanning came into play. In the past, for spanning concrete structures, large structures like that, ended up with a lot of wood formwork, cap beams, large beams, and typically they're custom in there, and a lot of shoring involved. So you can see the bottom left picture there. It's kind of hard to see. It's dark, but there's a lot of shoring underneath there. So you can imagine a lot of labor, a lot of time, a lot of cost involved in that type of formwork at the time. But there really wasn't another way to do it. In the mid 80s, you started to see all steel formwork that allowed customers to self-span, meaning they could go from column to column, greatly reduce their need or eliminate their need for shoring or custom equipment, and allowed the contractors to gang these into one big piece and set it as one big cap. So Obviously, that means improved efficiencies, a lot lower costs, less labor, and so on and so forth. So really a big advancement there in the forming industry. Now, recently, in the past decade or so, we've started to see concrete structures get bigger. Architects, engineers decide they want to make things bigger, stronger, span a lot further. Bridge caps, power plants, turbine pedestals, that type of thing. They're just getting larger. And what happened is you're starting to get back into the need of shoring back down to the ground or custom equipment, heavy duty shore frames. And we're right back to adding labor, adding time, cost to job sites. So that caused us here at Symons to take a look at our current self-spanning system, the Maxiform system, and to see what we could do with it. So the ability of STS, the advancement that we did from Maxiform to Maxiform STS, got us back to this look. Greatly eliminated or reduced or eliminated the need for shoring, got rid of a lot of custom equipment. So we're right back to reduce cycle times, reduce lead times because it's standard equipment, and really simplified, how you go after these self-spanning applications. So we basically jumped ahead a little bit to try and get ahead of the design phases that the engineers and architects were doing. Little detail on the advantage of STS and what it does for us. The new design has about 30% higher moment capacities or self-spanning capacities, as well as pore pressure ratings. You can see some of that detail over to the right. The shaded area is the older Maxiform with the face sheet. So we're comparing the old style Maxiform to the new style STS with the 3/16 face sheet to the 1/4 inch, and then the pore pressure, anything from 2 foot wide up to 8 foot wide, went from 1,500 to 2,000 pounds per square foot maximum capacity. You go above that 8 foot or 10 foot and 12 foot, they do come down a little bit, but again, we still gained, a good 30% plus in capacity as well. The deflection, we were able to maintain our deflection under L/360 at rated loads. And we did test that at University of Illinois under full pressure to verify that. So it has been through that testing phase as well as out in the market, for a better part of a decade. A big part about that as well is that we did maintain dimensionally. It's the same as the old style Maxiform. So that means a lot of the accessories fit right up to it. So no need for a lot of new accessories on the system. I will show you a little bit here in the next few slides of some of those accessories due to the loads that we're seeing that we did add to the system. Little look at the panel itself. Again, 3/16 a 1/4 inch face sheet, the steel face sheet. We went from what was called a Z stiffener to an L stiffener. So a simpler stiffener, a simpler load pattern, as well as we added some continuous backup stiffeners on the back side of the panel to reduce, to help control our deflections and reduce the amount of area for the deflection. The weight in the system did come up slightly, but again, we're talking about a panel and a system that is handled by crane. You're not going to be hand setting this system.
Unless you're Hulk Hogan.
Yeah, Hulk Hogan, maybe.
Who's mad?
A little bit of nomenclature for the system itself, top rail, bottom rail, and you've got the end rail around the outside. You can see on the inside the continuous backup flats. This happens to be a 12W panel by 8 foot. And the W, what that references is the width of the panel, or actually the length of that rib, or if you want to call it a cross member, a interior stiffener. It's called many different names, but that is 12 foot in this case. And then the 8 foot is how many spaces in between those stiffeners or those cross members. So there's 8 spaces. So this is a 12W by 8 foot. Something that we did with the design as well for manufacturability, consistency of the quality of the panel is we included tab and slot technology. So a lot of the parts have a tab and then corresponding slot that tab goes into. So in this case, you can see the rail on the outside. There's a slot that's actually put into the face sheet for that. There's also slots in the face sheet throughout the grid there, the face sheet itself that will take the interior stiffeners. Down at the bottom, you can see we also laser in the tie holes. We put those on one side of the form, is standard when it comes out of the plant. A little bit more, you can see here the top and side rails. So to really stiffen up the corners there, you can see our top rail around the corner wraps on top of the side rails. You can also see this also includes the typical tab and slot technology in it as well. Here you can actually see a picture of how it goes together. It really simplifies how it's produced. This really locks all the parts into space, into place, even before it's tack welded or finish welding is performed. So you can really see the slots there and the tabs and the corresponding members. Little details on what makes this work. You can see the tie box on the bottom left, the triangular shaped plates that we use for the tie box and the hole. And then the girder block that's placed into four corners. That's where we place a larger bolt, which I'll show you in a minute. And that's what helps generate our moment-to-moment connection or our self-spanning capabilities of the system. Where you're seeing at the top is a look at that backup plate that I mentioned to help our deflections come down. You can see that also includes slots where all of the stiffeners are going at 1 foot on center. So you can see everything just kind of locks into place. Standard sizes. So as I mentioned before, this is a rentable system. Anything that 2 foot W up to 8 W is 2,000 pounds per square foot maximum pressure. And you can see the reduction there as we go 9, 10, and 12 foot W as well. That is versus 1,500 at the 2,000 and then 1,000 all the way down to 1,000 on the old style Maxiform for the 12 foot. We're now up to 1,300 PSF. Anything 2 foot W to 7 foot W is 6.5 inches thick. So that's how deep the panel is, 6.5 inches. The 8, 9, and 10 go up to 8.5 inches. And then the 12 foot is much, that's a large panel, just over 10.5 inches thick. Our standard lengths within the fleet, 1 foot, 2 foot, 4, 8, and 12 for the majority of those widths. However, we can produce a lot of different lengths as well. You can see those. It really is limitless as long as we know what we're producing for a non-standard application, typically a purchase for a project, depending on what it is. We also have 2 foot 6 inch and 3 foot 6 inch wide panels. So that's 2 foot 6 W and 3 foot 6 W by 1, 2, 4, and 8 foot lengths. You see those a lot on soffits and columns as well. Tie locations. So what you'll see in some of the pictures coming up, STS is a fantastic system when you want to space out your ties or do a column. So the system is designed and the panels are designed to carry a load for that width, whatever the W is. So if it's an 8 foot W panel, it is designed to handle or span that load from end to end, 8 foot. So in this case, you can see these panels that are laid out, the W is going vertically, and then our ties are spaced 4 foot across horizontally. So you can see your different sizes, a non-standard 20 foot long panel, but your tie spacing starts at 2, and then every 4 foot, your 12 foot, starts at 2 every 4 foot from there. You can see the different lengths of panels across there. Some of the accessories that we added due to the higher pressures, we did change the outside corner to a 4 inch by 4 inch by half-inch steel angle, standard steel angle. So you can see that there. The girder bolts that I mentioned that allow for the self-spanning, those go into the girder blocks that I showed you earlier a couple slides ago. That's a 1 inch by 4 inch A490. That used to be an A325. So we up that. That's due to the tension load that goes through that bolt when we bolt the panels together and put them into a self-spanning application. We also have a handling hook when these panels arrive at site to help with shakeout and move the panels around off the truck. You can see on the left there a little bit of a look at horizontal application. So this is when you're wanting to span your ties out a little bit. So you can see where that individual is standing there. That's your rib or your cross member. So that form will span all the way across that, whatever width that is there. I'll show some pictures of columns as well. That has to do with that spanning as well of that W and doing it tieless. The tie systems as well, we did upgrade the tie systems due to the 2000 PSF rating. So we now have a standard, what we call super taper tie, uses, pardon me, a 5x7 tie plate, 32 millimeter threads on either end. It is a taper tie of 1.25 to 1.5 inch, and it handles 64,000 pounds safe working load. So ultimate load of 128,000 pounds. We also have a super she bolt as well. That standard capacity is actually 56,000 pounds safe working load. However, when needed, we can get that up to 64,000 pounds as well. It utilizes the same 32 millimeter thread, 5x7 tie plate. So those are standard in our rental fleet as well. This was a great ad, very exciting ad for us. Again, thinking back to, the added weights that are coming from these larger structures. We develop a standard 300 kip support system. So this is a standard rentable item, and it really is designed for the markets that we have here today. The only purchase items that you'll see, and I'll go through all the parts for this system, are the embed tubes, a plastic cap, and shim packs that are used with it.
Where do you put this thing?
That goes on the columns. I'll show you a picture here. Yep. So there's a couple pictures here. A round column on the left. So something we did add with this system were some column adapter brackets that allow us to handle that radius of a round column, anything from 6 foot all the way up to 11-foot diameter. We have 3 different sizes that'll handle those diameter columns. And then on the right, a more standard square column look. But everything you can see there is rentable except for the through bolts, or I'm sorry, the through tubes, and there's a plastic cap as well. Everything else is part of our fleet. Another item that we added were the extension tubes, 6-inch, 12, 24, or 36-inch extension tubes. Those can be placed on the threaded side of the through bolts, so we can greatly reduce the number of different lengths that we have in through bolts. And we can still, we just simply slide on one of those extension tubes and then put the nut on the side, on the outside, thread it down. And you can, we have 3-4 different lengths of that rod versus 15-20 in the fleet. Here's the main parts of that 300 kip. So you can see the bracket up on the left. It's a very large bracket. It stands about 5 foot 4 inches tall. So you can kind of get an idea of just how big that bracket is. The column adapter, there are 3 sizes I mentioned before. Those handle anything from 6 foot diameter up to 11-foot diameter, the 3 different sizes. 300K sand jack up there on the top for releasing the load, a spreader beam as well. Our 3-inch diameter through bolts and nuts, the embed tube and the cap there on the bottom right, those are purchase items. Everything else that you see here is rentable. So that's the system. A really quick rundown of the main parts of the system itself. Now we can take a look at the actual system in use on some standard applications. So here we have a bullnose crash wall where we've got, in this case, the panels are going horizontal, so your ribs are horizontal. As I mentioned before, the ties can be spread out here, so you can see from panel to panel, it spans all the way from one edge of the panel all the way to the other one. And then they're 4 foot on center vertically is what they typically are in this case. The tower max on the end there creates, it bolts right up and it creates the bullnose. Here you can see a large cap up in the air there on the left, as well as the columns there on the left, and then a closer look at some very large columns on the right. So this is where you really get an advantage with MaxForm STS and its ability to span that width, whatever that width of the panel is, that 8W dimension, for example, or 6 foot, 5 foot, 12 foot, whatever it is. This system will span across that distance without a tie. So you can have a 12 foot by 12 foot column in plan view and not have a tie in it and go as tall as you'd like. So that is a major advantage of MaxForm STS. A hammerhead application on the top left. So the soffit there, we've got a standard STS panel coming up for the soffit that we bolt into the sides of the panels as well. On the right side, upper right, you can see an offset support bracket down at the bottom. And then we're actually using a smaller W, probably a 2W STS for wind beams, and our standard soldier for the braces on that one. The bottom left is a look at a crash wall, a cap on top of a crash wall. And then the bottom right is just a smaller multi-stem cap. So those are some smaller applications. This is where we get really large bridge caps here. On the bottom left there, you can see a single set. So when way back at the beginning, I mentioned being able to set this as one big gang. That's all going in as one big cap there, setting on 300 kip brackets on a circular column. So there are 1, 2, 3, 4 300 kips on one side. So that's 1.2 and then 2 columns. So that is able to hold up 2.4 million pounds. On the right side, that's a double stack due to the, I'm sure the span there, but you can see in both applications there on the bottom, we're placing that over top of either a roadway or a railway to allow that to still be used while they can continue to work up top. Closer look at a column there at the upper left. So again, there's no ties in that whatsoever. They're just placing the sides of one of the sides of the column there. On the right, you can see some multi-lift columns, again, using STS panels. On the bottom left, you can see a couple larger support brackets and then distribution beams underneath, and then the standard STS panels to form the cap.
So I got a question here.
Mm-hmm.
Is the 3,000 or 300K parts the standard now? Or are the other smaller 70, 140, 150 spreader beams able to be used with the STS?
Yes, we still have all of those. Let me read that. So 300 kip is a standard rentable item. It's used when we have to have that type of loading, that type of support. The other, your 40K, your 12K, 40K, 70K, 140K, all of those are still available as well. we developed a 300K and put it into our fleet because of the loading or the load cases that we are seeing coming into the market. Yep, definitely.
Yeah.
The higher loads warranted the higher capacity bracket, but we still have all of those other.
So do you think that's normal to need that more often than not?
We've seen it. Just depends on the application, the size. I mean, some of the smaller caps that you saw there did not have the need for that bigger bracket. But some of the larger ones that you'll see here coming up, definitely we needed that higher capacity, and even one that you'll see here in a minute needed 500K. So that was a custom build. Couple specific projects, Grand Parkway project there on the right. So you can see the column and the cap, part of the cap being formed at once, and the finished concrete in the background there. On the left, the horseshoe project around Dallas. You can see, we've been talking about not using shoring, but in this case, it was a little different application. So we had to break that beam of STS panels. So you can see the shoring there in the bottom right that we had to add in that case. The finished concrete in the center in the bottom. On the bottom left, you can see the STS panels and then a custom radius soffit that we bolted in to create that look. Here you can see a couple uses, very tall columns there on the left. The Yerba Peninsula project between Oakland and San Francisco. Those are 100-foot plus tall STS standard panels used with a custom to create the corners. And then down at the bottom, I-90 Interbelt in Cleveland as well. Just to look at some larger caps there with some radius soffits that we can put in.
I was just on that I-90 3 months ago.
Yeah.
So good job for making it sturdy.
Good contractors there.
Yeah.
Tappan Zee that was done there over the Hudson a few years back on the left. That's a very large column. That was one I mentioned where we actually needed a custom 500 kit bracket that had 6-inch diameter through bolts. So our 300K has 3-inch. That was a 6-inch diameter through bolt through there. So very large application there on the left. And then the bottom, there was a project that we did over in Saudi Arabia where we use STS panels and some customs to do the support for the monorail. So not just bridges, but STS is used all over the place, really. Dams, water facilities, wastewater, water treatment facilities, lift stations. It's very good in the bottom left there for power plants, STGs or coker applications, and really a lot of special applications where we use it. It can be used in combination with Soldier, as you saw, our Tower Max, our Flex Form, our space lift. We put it on our space lift before. So a versatile product, very strong. It does have its uses out there where, in my mind, it is the best to use in a lot of applications. And our team is very well versed in getting it on the project and on the right project. So thank you for your time. Really appreciate the opportunity to kind of go through the basics of a great system that we have in MaxForm STS.
I appreciate you taking time out to teach us. And Tyler just mentioned, without mentioning it, the engineering aspect. I'm going to talk about some resources, but while you guys are putting in your questions, if you have any, go ahead and do that in the chat functionality or the QA of Zoom, and we can get them answered for you. Yeah, engineering is a big aspect that we can do here. And correct me if I'm wrong, but we start with the norm standard. And then if you need customization, we're here for you to take charge of that. And some of the pictures we would see here is this, but you said you built a 500 kit, which is not standard. So things can be done. Just contact us and we can make that happen, discuss it with you and figure it all out. So perfect example here, contact information. How the heck do you find it and where do you call? On DaytonSuperior.com in the top right, there's a contact us and it'll take you to this page. And there's a Symons map that you can utilize and you just simply click on your state that you're in or the project is in, and you can find the contact information, whether it be for the technical area, the engineers, or the sales management and the customer service. In addition, on DaytonSuperior.com, we've got product and system pages, as well as technical data sheets that I referenced early right before this presentation. And then we have some success stories. So the images that you saw, there may well be a success story, that's hard to say, on there's for you to read. On the landing page, you see that on the bottom right corner for the Maxiform STS forming system, and you can see how these are utilized. In addition, we have brochures as well as application guides and additional Symons videos and training. We've got a lot of training Tuesdays. He referenced the soldier beam, what else did you say? I can't remember. Yep, Tower Max. And yeah, we've got all of those out there. They are quick blurbs. These are intended to get you interested in the product, to know that what we have and to see what it's all about. If you need something more, longer, customized to fit your learning need, you can contact Chuck and or myself at training@DaytonSuperior.com. And I'm going to actually go to the next slide because there's a QR code there for you in the bottom right that you can simply scan, or you can see the training@DaytonSuperior.com email address. I go straight to Chuck and myself, and we can talk to you, get you set up with something, and take care of you. So are there any questions, guys and gals? I don't see anything coming through. Let me check real quick. All right, man, look at that, 1:30-ish. All right, so everyone have a great rest of your Tuesday. We appreciate you coming and hanging out. Tyler, thanks so much. Chuck, you too. You were very talkative this week. And we'll see you next week, guys. Thanks.